Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 141, which is called linked list cycle. So let's read the problem statement. Given head, the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Here it's just simply saying that they're giving us a POS parameter, which is called position, and that just tells you where the loop is. So for example, POS1 means that the node at position 1 is where the loop starts. Here, position 0. But it's not really passed on to the method, so don't worry too much about that. So return true if there's a cycle in the linked list, otherwise return false. So example 1 obviously has a loop, as we can see. Example 2, the same thing. And example 3 doesn't. So if you want to start working on this problem by yourself, now will be the time to pause the video because I'm going to explain how to solve this. Alright, so I guess let's try to think about the easiest approach first, right? We could, for example, use a hash table or a hash set, right? And we could just traverse the nodes of the graph, right? And whenever we encounter a node that has already been visited, and as we visit each node, we store them in, let's say, a hash set. Whenever that happens, then we know that since we've encountered that node before, that means that there's a cycle by definition, right? Because we've encountered a node that we've visited already, and that only happens in the link if the linked list has a cycle in it. And that could be an approach. It definitely solves the problem, but there is an approach that uses big O of one space, because that approach that I just mentioned before uses big O of n space, because in the worst case scenario, every single node in the linked list is stored. So let's try to think about a different way, right? How can we use big O of one space to do this? So if you want to take the time to think about it, pause the video because I'm going to explain it now. So the main idea here would be to use two pointers. And we're going to use something called Floyd's algorithm, which is an algorithm to detect a cycle in a linked list. It is also known as the tortoise and hare algorithms. You might have covered that in your algorithms class. It's a fairly famous algorithm, but don't worry if you don't know it. This is why I made this video. So the main idea behind this algorithm is the following. We're going to use a slow, or the tortoise, pointer, and then a fast, or the hare, pointer. And the main idea is that we are going to start with a slow pointer in the first element of the list. And we are going to use we're going to start the fast pointer, or the hare, in the second element of the list, if there's any. The main idea is whenever the slow pointer is moved, because we're going to move it every iteration of the cycle, we're going to move it by one node. And the hare, or fast node, is going to be moved by two nodes, right? So for example, in the first iteration, we would start, first we start with a slow at 3 and the fast at 2. And the slow one after the first iteration will go from 3 to 2, while the fast one will go from 2 to 4, because 1 and 2. And how do you know this algorithm works? Well, let's try to think of the two cases and whenever there's a cycle. Obviously, if there's no cycle, simply what we need to do is, we know that the fast node is always going faster, right? So whenever the fast node is equal to a null pointer, or another case, which I'm going to discuss in a little bit, when that happens, then we've simply reached the end of the cycle. And since we've reached the end of we've reached the end of the linked list. And whenever we've reached the end of the linked list, that means that there is no cycle. So suppose that the list just looks like this, like a 3, 2, 0, and a -4. And we start with a slow and a fast. This is no cycle, right? So we move the slow by 1, and then we move the fast by 2. Now, what we have to check for is whenever either the current fast pointer is equal to none, that means that we have reached the end of the list, or whenever the next element that goes after fast is equal to none, because we're going to be moving the fast, let's say, if we are at some pointer, right? Whenever we update fast, we're going to say something like fast is equal to fast.next.next. But suppose that fast.next is null. Then this will throw an error because none does not have a .next parameter in it. So that's why we are checking whether fast is equal to none or fast.next is equal to none. In this case, there will be no cycle because fast.next would equal to none. Now, what happens, right, if there is a cycle? Well, there are two different types of cycles. You can have a cycle of odd length, and you can have a cycle of even length. So let's explore both cases. So we start with a slow and the fast pointer, and this will be just a cycle that goes from -4 to 2. So first we move the slow one by 2, and then we move the fast one from 2 to -4 because we move it by 2. Are they pointing to the same node? No. Then we continue. We move the slow one by 1, and then we go from the -4 to the 2, so that's 1, and then to the 0, so that's 2. And at this point, they point towards the same thing, so there is a cycle. So the case where there's an odd length, we can see that it works, but what if there's an even length cycle? So suppose that, again, the -4 is pointing towards the 2, and then we start again. Let's start with a slow here, and the fast pointing towards the 2. So we move the 3 by 1, so towards the 2, and now the fast one points towards the 1. Same thing here now. S points towards 0, and 1 goes to -4, and then to 2. And now we move this one by 1, and then we move this one by 2. And as we can see, they both end up in the same thing, so they detect the algorithm. So yes, it works both on even length cycles and odd length cycles. So let's get to code it. So we start, first of all, if one of the base case, right, will be if the head is none, meaning that there's no linked list, then obviously by definition, right, there is no cycle. So let's start with that. So if the head is none, then we return false. And now let's start initializing the variable. So we can say slow is equal to head, and fast is equal to head.next. And we're going to keep looping this, right? The main idea is we're going to do this until both pointers point to the same thing. And whenever that happens, we know it's true. So we can simply set a while loop that says while slow does not equal fast. Whenever we exit that, then we will return true. And the only time that we will return false, we will have to check within the while loop. And when is that? Well, we discussed it before in the video. So that's if fast is equal to none, or if fast.next is equal to none. And remember, you should always check this first, because if fast is none, and we put this before this, right? Then whenever fast is none, this will throw some sort of error, because if fast is none, then none does not have a .next parameter. So it's always important that you check fast equals none before this. So this is the case we return false. And if that's not true, then we just keep going, and we just have to move the pointers. So slow is equal to slow.next, and fast is equal to fast.next. And this should work. Obviously, as usual in all my videos, runtimes are inconsistent, but I tested it before. It beats like 90% of submissions eventually. You just have to submit it a couple times. Good enough. There you go. So yeah. Now let's discuss the runtime and the spacetime of the algorithm. So the spacetime complexity of this algorithm is big O of 1 because we're simply using 2 pointers, and it's definitely not proportional to the number of nodes. And the runtime of this algorithm is big O of n, where n is the length of the linked list. It is possible that we visit the nodes more than once. However, it will not be quadratic. So just keep that in mind. It's still big O of n. But we may visit more than we might visit like a node more than once, especially if there's a cycle, right? But you will not be looping this like n times. if that makes any sense. So it's definitely still a big O of n. So yeah, that'll be it for this video. I hope you enjoyed it. Make sure that you hit the like button, which helps a lot the channel. And see you in the next one. Bye-bye.